Hey, good morning. Just wanted to hop on here real quick and just explain the extra practice problem that was posted on Friday. Some people still have questions, so I just thought I'd speak to this real quick. This is just an optional video. Watch it as you need be, and we'll continue our notes for this chapter later on today. So, for number one, we're given a little scenario here, and we just have to define the HO and the HA. Remember, the HO will always be equal to. I will always be an equal to. Now, the letter that is included there, like the little cursive M, stands for mean or mu. And that's because we're talking about mean weights in 1A. In B, you see me put a P in there for proportion because we're given proportions. So whatever the parameter is, that's what you would include here, okay? So it says the mean weight of the bread loaves, okay, so is equal to 1 pound. It's supposed to be 1 pound. So that's our HO. Then we have a suspicion or a concern that new personnel are making loaves of bread that are more than one weight or more than 1 pound. So the HA would be mu greater than 1. For B, it talks about proportions. And again, it's always equal to. So it says 33% of households have at least one cat. So P equals 0.33. Now the HA could be a less than, a greater than, or not equal to. You have to read the problem and interpret which one they're asking. So it says in this scenario that you're wondering whether the proportion of households of students at your school that own at least one cat is different. Doesn't say greater than, doesn't say less than. So that's simply a not equal to. It's something different than 33%. Okay. All right. For 2A, we have to interpret p-value. P-value means it's a probability. It's the likelihood something would occur. So in this case, if the mean weight of the bread loaf really is supposed to be 1 pound, yet you took a sample and your sample got an average of 1.025, well, the chance of that happening was 0.086. All right, so assuming the mean weight of bread loaves really is 1 pound, there's a 0.086 chance of getting a sample mean like we did of 1.026 pounds or more. All right, so the p-value is the likelihood an event occurs, your sample occurs, given the HO has occurred. As far as conclusions go, well, we make our conclusion by first looking at the p-value and comparing it to these two significance levels, they're called. All right, 0.05 and 0.1. In other words, this is 5% and this is 10%. Okay. If this number here, which you can think of as 0.086, or if you need, you can think of it as 8.6%, but you're comparing this number to these two, one at a time. All right, so at 0.05, our p-value is greater than that number, which means we fail to reject the HO. Anytime this is bigger than this, we fail to reject the HO, meaning we don't have evidence that shows that the weight of bread loaves is really greater than 1 pound. So the conclusion is always two parts. The first part speaks to the HO. We fail to reject it. The second part is about the evidence in the HA. All right. And then for 10%, this number now is less than 10%, which means our conclusion changes. All right. We now reject the HO. Why? Why would we reject this idea of it being equal to 1 pound? Well, because we have evidence that the mean weight really is greater than 1 pound. Okay. So when you make conclusions, compare your p-value to the significance levels. All right, guys, like I said, just hopefully take a few minutes, watch this video. Hopefully it'll help you better understand it. We'll continue the notes and continue practicing more so today. All right, thanks, guys.